What is long division? Long division is a way to undo multiplication. For example, we can write the division problem 35 divided by 7 as a fraction, 35 over 7, or simply the equation 35 divided by 7. Lastly, the long division way to write it would be 35 divided by 7 as written. These are all ways to write division. We can break down 35 divided by 7 into a multiplication and addition problem. First, we can break 35 into 30 plus 5. Then we break 30 into its factors 6 and 5, and 5 into its factors 1 and 5. We notice a common factor of 5, and we add the factors that are not 5, 6 and 1. We get the answer 7. So we find that 35 is really 7 times 5. In other words, we found how many 5s there are in 35, 7. Here is the long division way to do the same problem. One way is to write the problem as a fraction, 35 over 7. From there, we find the common factor of 7. We cancel out the 7, and we are left with 5. In long division, we write 35 under the bar, 7 to the left of it, and we write the factor 5 on top. Together, we get 7 times 5 equals 35, and we are left with a remainder of 0. Both of these get us the answer 5 with 0 as the remainder. What happens when we add 10 or more to the dividend? First, we can try the number 45 divided by 5. Using our multiplication facts, we find 9 times 5 is 45, which leaves us the remainder 0. Then we move on to 10 greater than 45, 55. This is not a multiplication fact, but we know that 11 times 5 is 55. Look at how we break down the long division problem. First, we look only at the first 5, and using 10 times 5, we get 50. Then we use a 5 in the singles place, and we also get 5, leaving us a remainder 0. Although we could have done the problem using just multiplication knowledge, we also see how long division gets us the same answer. Lastly, we try to add 20 more than 45, which gets us to 65. This is not as immediate, and we have to use long division to get us the answer. We find that 5 goes into 6 one time, leaving us with 10 times 5, which is 50. Then we use a subtraction problem to get us 15 as a remainder to the problem 60 divided by 5. In the second step of the problem, we find that 5 times 3 is 15, and that gets us a remainder 0. Since all three of these numbers ending 5, it makes sense that none of these problems have a remainder. Let's look at a problem where we do have a remainder. We can use 71 divided by 6. We cannot solve this problem using multiplication facts, so we use long division. We first find that 6 goes into 7 one time, leaving us with 6 times 10, which is 60. Then we get 11 as a remainder to the first problem. We find that 6 goes into 11 just one time as well, leaving us with 11 minus 6, which is 5. So the answer to the problem is 11 with a remainder of 5. Let's try this problem using grouping. From our knowledge of multiplication, we can infer that 6 times 11 is 66. 66 plus 5 is 71. We can use grouping to represent the same problem, and we get the same answer. Grouping or long division are both strategies to help us get the answer to division problems. How do we talk about division? We can use our knowledge of fraction to help us make sense of division. In this problem, we use a familiar fact: 100 divided by 4 is 25. The number 100, the bigger number, is a dividend. In a fraction, it can also be known as a numerator. The smaller number in this case, 4, is a divisor, or denominator. It's a number we are dividing by. In this case, we get 0 as the remainder and 25 as the answer. As a fraction, we can write it as 100 over 4, which is 25. Make sure that you know the dividend can sometimes be smaller than the divisor. In that case, we would get a number smaller than 1 as the answer. Now try these division problems. Think of which problems might have remainders and which ones might not. When you look at a problem like 55 divided by 9, the first digit, the digit in the tens, won't have any number over it. When you look at the third problem, 125 divided by 6, you'll notice that 6 times 2 is 12, and you will just be left with the number in the ones digit to do the remainder with. Try to notice patterns in these problems and think about how multiplication facts can help you.